Let's look at another way to solve our trig equations, and that's going to be using the identities that we've practiced in a previous section or a previous chapter. So for these two examples, I am only going to find the solutions that lie on the interval between 0 and 360. I don't need all the solutions, just the ones that are occurring between 0 and 360. So we have this equation here which says cosecant squared theta minus 2 cotangent theta. They're not the same trig terms. I couldn't factor at this point, so let's apply a trig identity for this. I recognize this cosecant squared theta, and I can use the Pythagorean identity which says cosecant squared theta would be equal to cotangent squared theta plus 1. So let's replace cosecant theta with this idea over here. So this is cotangent squared theta, plus 1 minus 2 cotangent theta. Now what did that get me? That got me an equation over here on the left-hand side that is in terms of the same trig function. So it's all in terms of cotangent. Let's remove this parentheses and rearrange this so that it looks like cotangent squared theta minus 2 cotangent theta plus 1 equals 0, and I can now factor. So if I were to factor this, I would recognize that this is going to be cotangent theta minus 1 quantity squared, because the first term is a perfect square, the last term is a perfect square, and the middle is twice the square root of those two numbers. So that's just one of those special ones, remember, that I asked you to learn. So this is cotangent theta minus 1 quantity squared is equal to 0. To solve that, we would take the square root of both sides, and that gives me cotangent theta minus 1 is equal to 0. We're going to add 1 to the other side, and I see that cotangent theta is equal to 1. So I ask myself, for what angle, when I take the cotangent of it, do I get back a positive 1? Well, that must be angles that are occurring in quadrants 1 and 3, and therefore I'm looking at 45 degrees in quadrant 1 and 225 for the angle in quadrant 3. Okay, so we used the Pythagorean identity, replaced it, and then solved from there. Let's try one more together. It says 2 sine theta minus 1 is equal to cosecant. Again, these are not in the same, they're not the same trig terms, so I can't factor, I can't do anything, I can't gather like terms, so I need to put them in the same term. So I'm going to use the reciprocal identity on the right-hand side over here. And I'm going to rewrite cosecant as 1 over sine theta. And that's equal to the left-hand side, which stayed the same as 2 sine theta minus 1. So I have all signs, but now what do? I have a sign in the denominator, so we're going to cross multiply. So I'm going to multiply both sides by sine theta. That gets rid of the sine theta on the right-hand side, and it gives me on the left-hand side sine theta times 2 sine theta minus 1 is equal to 1. Since this is not equal to 0, I can't take each of these factors and just automatically set them equal to 0, because it has to be equal to 0 in order to use that property. So we're going to actually distribute sine theta and then collect our terms on the same side. So this becomes 2 sine squared theta minus sine theta is equal to 1, and now I'm going to subtract 1 to the left, and I get 2 sine squared theta minus sine theta plus, minus 1 is equal to 0. Now let's factor this. Okay, if we factor this, we see that this is going to factor into 2 sine theta plus something and just sine theta minus something, and this has to be a plus 1 and a minus 1. Let's see if I have the minus sign in the right spot. This is a negative 2 plus 1 gives me a negative 1. So just by chance, I did it right the first time. Now that I have these factors set equal to 0, I can set each of those to 0 and solve. So I have 2 sine theta plus 1 equals 0. Sine theta minus 1 is equal to 0. Solving the left-hand equation, I get 2 sine theta is negative 1. So sine theta would be negative 1/2. And over here, I add 1 to the other side, and I see that sine theta would be positive 1. So now I have to decide on each of these, what is the angle represented when I take the sine of it, I get that answer. So on the left-hand side over here, when I take the sine of something, I get negative 1/2. Well, that's occurring in quadrants 3 and 4, and so that value would be 210, and again at 330. And then for what angle when I take the sine of it I get a positive 1? Well, that's occurring at 90 degrees, so I'll just stick that one on there. So those are the 3 angles that I'm going to get when I solve this equation. So you can see that we can use our identities to get everything in the same terms, all of the same trig term, to then solve.